For more than half a century, two small machines have been drifting silently through the darkness, far beyond the warmth of the sun, far beyond the planets, far beyond anything humanity once believed marked the end of home. When NASA launched Voyager 1 and Voyager 2 in 1977, no one imagined they would still be alive decades later. They were built for a short mission by today's standards, a daring flyby of the outer planets, a brief glimpse of Jupiter's storms, Saturn's rings, and then silence. Instead, Voyager refused to die. It kept going, crossing invisible distances, outliving its creators, carrying humanity farther than any object ever had before. As the years passed, Voyager moved into regions where sunlight weakened into a pale memory and the sun itself became just another bright star. Signals grew faint, taking hours to reach Earth, whispering across billions of kilometers of emptiness. And then, quietly, without celebration or fireworks, Voyager approached something no human eye had ever seen, the true edge of the solar system. Not an edge marked by planets or rocks, but an invisible frontier where the sun's power finally begins to fail. For a long time, humans believed the solar system was a neat and orderly place. Planets orbiting a star, surrounded by emptiness, separated cleanly from the rest of the galaxy. Voyager shattered that illusion. What actually surrounds our planetary system is a vast, invisible bubble formed by the solar wind, a constant flood of charged particles streaming outward from the sun at incredible speeds. This bubble, called the Heliosphere, has acted like a cosmic shield for billions of years, deflecting dangerous radiation from deep space and quietly protecting everything inside it, including Earth. But every shield has a limit. As Voyager moved farther away, its instruments began to notice subtle but terrifying changes. The solar wind weakened. Particles that once flowed strongly from the sun slowed, thinned, and then almost disappeared. At the same time, something else surged forward, high-energy particles from outside the solar system, cosmic rays born in distant supernova explosions and violent stellar deaths. The balance of power was shifting. Voyager was leaving the sun's kingdom and entering a region ruled by the galaxy itself. In 2012, Voyager 1 crossed that boundary. Humanity officially entered interstellar space. Yet what Voyager found there was not what scientists had predicted. For decades, models suggested the boundary between the sun's influence and the galaxy would be violent and chaotic, with magnetic fields clashing and twisting against each other like colliding storms. Instead, Voyager sent back data that felt almost wrong. The magnetic field beyond the solar system was strangely aligned with the one inside it. There was no dramatic rupture, no sharp divide. The transition was smoother, thinner, more intimate than anyone had expected, as if the sun and the galaxy were not separate realms, but parts of a single, interconnected system. This discovery forced scientists to confront an uncomfortable truth. The solar system is not isolated. It is not sealed off. It is immersed in the galaxy, constantly shaped and reshaped by forces far beyond our control. Then Voyager revealed something even more unsettling. Interstellar space was not empty. The density of plasma, charged particles drifting between the stars, was higher than predicted. Space beyond the heliosphere wasn't a silent void, it was a pressured environment, pushing back against the sun's expanding wind. The heliosphere itself appeared compressed, distorted, almost fragile in places. This meant the protective bubble shielding Earth might be thinner in certain directions, weaker than humanity had ever believed. The implications were enormous. If the heliosphere could be squeezed by changes in the interstellar environment, then Earth's long-term safety from cosmic radiation was not guaranteed. Our planet's calm, life-friendly conditions suddenly felt less permanent, less assured. Voyager wasn't just exploring space, it was exposing the vulnerability of our existence. And then came one of the most haunting moments of the entire mission. Voyager's instruments detected oscillations in the plasma beyond the solar system, ripples caused by shockwaves from solar eruptions traveling billions of kilometers into deep space. When scientists converted these signals into sound, humanity heard something no one had ever heard before: the low, rising hum of interstellar space itself. It wasn't silence. It was a distant, eerie resonance, the background noise of the galaxy. For the first time in history, humans didn't just imagine the space between stars. They listened to it. Years later, Voyager 2 followed a different path and crossed the same boundary from another direction. Scientists expected variation, What they received instead was confirmation. The same magnetic alignment, the same unexpected plasma density, the same thin, fragile frontier. Two spacecraft, billions of kilometers apart, told the same story. Our understanding of the solar system's edge had been incomplete. Perhaps the most astonishing part of this journey is not the discoveries, but the machine making them. Voyager runs on technology older than modern computers, weaker than a smartphone, powered by a slowly dying nuclear battery. Its memory is tiny, its communication painfully slow, and yet, it continues to send data from a place no human has ever reached, a place no mission was ever designed to explore. Every signal Voyager sends is a message from beyond the sun's reach, a reminder that humanity has already stepped into the galaxy, even if only through a fragile, aging machine. Floating with Voyager is a golden record, carrying the sounds of Earth, human voices, music, and greetings, a quiet declaration that we existed, that we wondered, that we reached outward. Voyager did not find an end to the solar system. It found a transition, a reminder that borders in the universe are not lines, but gradients, where one reality slowly fades into another. The sun's influence weakens, the galaxy presses in, and somewhere in between, our tiny world continues to exist, protected, but not invincible. And this was only the beginning of what Voyager revealed. Once Voyager crossed beyond the Heliosphere, the reality it revealed was not just scientific, it was deeply unsettling. Almost immediately, its instruments began detecting a dramatic rise in high-energy galactic cosmic rays. These were not particles from the sun, but fragments of distant catastrophes, supernova explosions, collapsing stars, and violent events occurring light years away. For the first time, humanity was directly measuring the raw radiation environment of interstellar space, and it was far more hostile than anyone had expected. What disturbed scientists most was not just the intensity of this radiation, but its consistency. The galaxy was not randomly dangerous, it was persistently so. Outside the sun's protective bubble, space was saturated with energetic particles moving at near relativistic speeds. Voyager made it clear that life inside the solar system exists under a fragile umbrella, one that, if weakened even slightly, could expose planets to a relentless cosmic assault. This realization forced scientists to reconsider the past. Mars, with its weak magnetic field and thin atmosphere, suddenly looked less like a mystery and more like a warning. As data continued to arrive, another uncomfortable possibility emerged. The heliosphere, the vast bubble shielding our solar system, is not static. It expands and contracts as the sun's activity rises and falls, but it is also shaped by the galactic environment itself. Our star is moving through the Milky Way, passing through regions of varying density and magnetic pressure. Voyager's measurements suggested that if the sun were to enter a denser interstellar cloud, the heliosphere could compress dramatically. Earth would not instantly become uninhabitable, but increased radiation exposure over long timescales could disrupt biology, damage DNA, and alter climate stability. For the first time, the galaxy itself appeared as a factor in Earth's long-term survival. Then came one of the most haunting confirmations of all: interstellar space is not silent. Voyager detected plasma oscillations, subtle vibrations in the charged particles between the stars, triggered by shockwaves from solar eruptions that had traveled billions of kilometers. When translated into sound, these oscillations produced an eerie, rising tone. It was not a message, not a signal, but proof that the space between stars responds, resonates, and carries memory of distant events. The universe was not an empty stage, it was an active medium. Voyager also revealed that the boundary between the solar system and interstellar space behaves less like a wall and more like a living membrane. Particle counts rose and fell unexpectedly near the heliopause, suggesting a fluctuating frontier constantly adjusting to pressure from both sides. This meant the solar system's edge was thinner and more dynamic than previously believed. Humanity was not sealed off from the galaxy, we were immersed in it. At the same time, the spacecraft itself was aging. Voyager's power supply, driven by decaying plutonium, was slowly fading. Engineers were forced to shut down instruments one by one, carefully rationing energy to extend the mission for just a little longer. Each shutdown was permanent. Each lost sensor marked the end of a unique perspective humanity would never recover. And yet, even as it weakened, Voyager continued to transmit, quietly, faithfully, like an explorer determined to report until its final breath. As its discoveries accumulated, Voyager's role shifted. It was no longer just a probe. It became humanity's first true interstellar presence. Drifting through space was the golden record, carrying music, greetings, and sounds of Earth. Not as a message demanding a reply, but as evidence that a thinking species once existed and dared to reach outward. Whether or not anyone ever finds it no longer matters. The act itself changed us. The deeper Voyager traveled, the clearer one truth became. Every answer created new questions. If our heliosphere is fragile, what about other stars? Do most planetary systems exist without meaningful protection? Is life rare not because chemistry is uncommon, but because survival in the galaxy is difficult? Voyager transformed the universe from a romantic backdrop into a challenging environment, dangerous, vast, and precious. Voyager continues forward even now, its signal growing weaker but its meaning growing stronger. Every kilometer it travels pulls humanity further into a galactic context we can no longer ignore. The edge of the solar system was never an ending. It was a revelation. As Voyager moves farther into interstellar space, something profound begins to happen, not to the spacecraft, but to us. The numbers it sends back grow quieter, slower, and fewer, yet the meaning of those numbers grows heavier with every passing year. Voyager is no longer just exploring distance, it is exploring time. It is moving into a future where Earth may look nothing like it does today, where civilizations may rise, fall, and be forgotten, while a small, aging machine continues its silent journey through the galaxy. What Voyager has ultimately revealed is not a destination, but a condition. Interstellar space is not a place of nothingness, it is structured, pressurized, energetic, and unforgiving. The sun's influence fades gradually, not suddenly, and beyond it lies a galaxy that is constantly active, constantly shaping everything within it. This realization quietly changes humanity's self-image. We are not residents of a closed system. We are participants in a much larger environment, one that does not notice us but affects us nonetheless. There is also an unsettling humility in Voyager's final phase. Every year, its power decreases. One by one, instruments fall silent forever. No repair is possible. No upgrade will come. One day, the last transmitter will shut down, and Voyager will stop speaking to Earth. There will be no dramatic ending, no final message, just the absence of a signal. And yet, that silence will not mean failure. It will mean completion. Long after that silence begins, Voyager itself will still exist. It will drift through the Milky Way for millions, perhaps billions of years, passing through regions of space that have never known a human presence. It may someday glide past another star system, or it may wander endlessly through the dark between stars. Either way, it will remain a physical trace of a species that once looked at the sky and refused to accept limits. Attached to Voyager is a record not meant to conquer, warn, or explain, only to say that we were here. The golden record does not claim importance. It carries laughter, music, greetings, and simple human sounds, preserved not for certainty, but for possibility. Even if no one ever hears it, its existence marks a turning point, the moment humanity chose to represent itself beyond its home world. Voyager also leaves behind a deeper lesson, one far less technical than its data. It reminds us that protection is temporary, that stability is conditional, and that survival in the universe is never guaranteed. The heliosphere shields us now, Earth's magnetic field protects us now, our atmosphere sustains us now, but none of these are permanent. Voyager did not deliver fear, it delivered perspective. It showed us that life is rare not because the universe is empty, but because endurance is difficult. And yet, this story is not pessimistic. It is quietly hopeful. Against all odds, Voyager has survived longer than anyone expected, traveled farther than anyone planned, and taught us more than anyone imagined. It proves that even fragile things can go incredibly far if given time, purpose, and curiosity. In that sense, Voyager is not just a spacecraft, it is a mirror. When future generations look back at this mission, they may not remember every discovery or every measurement. What they will remember is that at some point in history, a small civilization on a pale planet reached the edge of its understanding and chose to keep going anyway. Not for profit, not for conquest, but simply to know. Voyager did not find a boundary marking the end of the solar system. It found continuity, a gradual blending of star and galaxy, of influence and exposure, of safety and risk. And in doing so, it quietly told us the truth. There is no final edge, only farther horizons. One day, Voyager's voice will fade completely. But by then, its job will already be done. It will have carried humanity out of isolation and into context. It will have taught us that we are small, vulnerable, and temporary, and that these qualities do not make us insignificant. They make our curiosity extraordinary. Voyager is still traveling, and because of it, so are we.